My name is Joe Nordling, and I'm a current senior studying computer science while also getting my master's degree here at KU. I want to show you around the ECS department of the region's only Tier 1 research institution. Let's check it out. This is the ECS Senior Design Capstone Lab. KU actually has a really unique approach to their senior capstone projects. So ECS students work in a small group to develop a project, whether that be an app or a website or a prototype of something that they want to design and build over the course of a year. I think my friends are working on their capstone project right now. Let's check it out. Hey guys, what are you working on?
Hey Joe, we're working on our senior capstone, which is a mobile application that allows users to share photos of their food, including location and recipes.
That's really cool. Let's check out my capstone project from last year. This is my senior capstone project from last year, where we designed a AWS Deep Racer car to drive the front 9 holes of Lawrence Country Club automatically. KU provides all of the hardware you need for any sort of project for your senior capstone. Let's go look at the ECS shop where you can pick up all of this hardware. This is the ECS shop, where students can pick up any hardware materials that they'll need for any of their classes or their senior capstone project. For your senior capstone project, you can also order parts online to use within your project. All of that is totally free for students to use. And if you can't find those materials online, we can actually make them here in the ECS shop through 3D printers or laser cutters. This is the Fishbowl, one of our main computing labs here on campus. We have access to Linux computers labs, Windows computers, and Macs for our students, open 24 hours. Here on campus, students have access to over 15,000 cores, nearly 100 terabytes of memory, and over 100 GPUs to run their projects off of. I think I see my friend Froggies. Let's see what she's working on. Hey Froggies, what are you working on?
Hey Joe, I'm actually getting ready to travel to Grace Hopper Conference with KU Women in Computing Club. It's one of the biggest tech conferences out there, and it's geared towards women in tech.
Oh, that's awesome. What are you most excited for?
So this conference has one of the biggest career expos of all time, and I'm really looking forward to seeing all the companies that are coming there, from big tech to startups.
Nice. And after you graduate this year, do you have any plans?
So this summer I had an internship with Microsoft, and I am just about to sign a return offer for them for full-time post-grad.
Awesome. Congratulations. Well, I'll let you get to it and I'll see you around.
Thank you.
This is KU's Cybersecurity Lab. KU's cybersecurity program is one of the top in the country, with endorsements from the DoD and NSA. Here in this lab, students work in classes to learn how to defend against malware and also design malware in order to learn how to best prevent it in the future. Let's see what's happening in the anechoic chamber, one of the research facilities we have here on campus. I think my friend Arul's working inside. Let's see what he's up to.
Hey Joe, thank you for the segue and welcome to the anechoic chamber. My name is Arul Sethi, and I'm an undergraduate research assistant at the Center for Remote Sensing of Integrated Systems. I'm going to showcase one of the projects that I'm working on here. The anechoic chamber is one of KU's state-of-the-art facilities where our lab deals with really high-precision radars, so we do a lot of our testing in here because of the really high electromagnetic capabilities of this chamber. So this project here is a test board to determine whether there's interference in a Cat6 Ethernet cable in a plane. So the idea is we're going to have a board in the nose cone of a plane and another board in the back of a plane, and we're going to be running one of these Cat6 Ethernet cables between those boards, sending a signal through the cable. And we want to make sure there's no interference between the wires in that cable to make sure our signal gets through properly. So what I've done here with the board is I've taken the schematic, which was given to me by a research supervisor, and turned it into a PCB, a printed circuit board design, in a software called Altium. And then we used one of our in-house manufacturing capabilities to actually make the PCB, which you can see here, a lot smaller than the one in the design, where we'll actually get a chance to hook it up to a vector network analyzer and test it. So the goal of CRESIS is to map the world's ice sheets. What we do is we'll take planes down to places where there's tons of ice sheets like Antarctica and Greenland, and then attach radars to the bottom of those planes, fly those planes over these regions, and map the ice sheets through there. A lot of the work that we do is in conjunction with NASA, and they use a lot of our data to model how ice sheets are going to melt and change over the next few years. A lot of it is due to climate change.
Approximately 90% of all ice sheet radar sounder data collected in the world is mapped through KU laboratories.
I'm so glad I was able to show you a bit of the department today. Hopefully, you can come on campus for an in-person visit of the department, and maybe even one day become a Jayhawk yourself. Rock Chalk.